Today, the lecture will be handled by Vladislav, and we decided to not perform all of lectures online, and I think it would be great to work near the blackboard in a classroom. And Vladislav will handle the topic related to the elections. So, Vladislav, floor is yours, and let's start.
Okay, thank you.
Thank you.
Guys, today we're going to discuss a very important topic. It's linked lists, queues, and steps. This is a pretty abstract topic. This is data structures. So knowledge about those concepts will differentiate you from guys who just finished some IT courses, because it's a fundamental knowledge. So, and also information about those topics, some algorithms that connected to those topics will be important for you when you will apply for some job, because this is pretty normal and basic questions on interviews in any company, in any Ukrainian company or international, even Google and Meta, they use those questions about such things. So I hope you will understand those topics well. So I want to share with you my story about algorithms and data structures. So when I was studying in university, we had a whole course about data structures and algorithms, and I just loved this topic, because for me it's such a pleasure to recreate some abstract, totally abstract topics in a code. So you're just having some thoughts, some abstract materials, and you can create something that you can see and touch in code. So I hope you will share my passion about algorithms and data typing. So what is a linked list? It's a data structure used for collecting sequences of data that allows efficient adding and removal of elements in the middle of the sequence during iteration. So what does it mean? Let's imagine some data storage. For example, our
Could you like move the Zoom window a bit up to the upper corner because we
no.
just
Yeah.
like this.
Yeah. Okay. So we have, for example, an SSD. And let's imagine our data storage as a matrix of cells that store data, right? So we can abstractly imagine our SSD as a matrix of data cells, and every cell have its address. So, for example, we have rows, we have columns. Every element will have some address. For example, this cell have address O2. This cell will have address N2, right? You remember an arrays. You used arrays. So what's an array? Who can tell me?
It's just a set of some elements of the same type.
Yeah.
It is on the fixed side.
Yeah. And totally correct. But other thing about an array, it's stored in memory continuously. So when we create an array, for example, we want to create an array size of 5, right? We searching in our memory some place where we can have 5 free spaces in our memory. For example, we have some information here, maybe some information here, some information here, but here we have free memory. So we say that we will allocate 5 cells for our array. And now this space reserved for our array. And now we can add elements, for example, 5. And those elements will be in our array. This element will have index 1, 2, 0, 1, 2, 3, and 4. And we know that our array starts from the element 02. This is an address of that element. But that element have index 0 in terms of array. This is clear.
Yes.
Okay. Anthony, thank you. So, how does array work? We know for sure that every element is physically in memory after each other. So, if we want to have element with index 2, we can just calculate address of this element. So we store address of element 0, and we can just add our index to this address to have this element, because address of this element will be something like this. So this is pretty abstract explanation. In real life, the different form how those addresses are written and stored, but like for your better understanding of those concepts, when we want to get element 2, we just calculating its address, and this is how arrays work. So if we will move to linked list. What's a linked list? So, for example, we have element 7, we have element 9, we have element 0. Those elements are stored in different places in memory, but this is the first element, this is second, this is the third. And how can we know where our first, second, and third element? I will tell you. So when we're talking about linked list, we can add another concept. It's a node. So node contains an actual value, for example, 7, and also it's contain 2 fields, next and prev. So next, it's a reference to the next node, and prev, it's a reference to the previous node. And basically, those references are addresses in memory. So our node already contains information about address of next element and address of previous element. So if our 7 element is first one and 9 is second one, this node will store in variable next reference to the next one, and in previous it will store nothing. It will be null because the 7 is the first element. And then our node 9 in the field ref, it will store reference to 7, and in the field next, it will store reference to this element. And this element in the field ref will store information about previous element, and in the next, it will store null because there are no next elements. So the main difference between linked list and array, it's a positioning in memory. And array stored physically, elements in array stored physically close to each other. When elements in linked list can store anywhere in memory, but every element of linked list store information about next element and previous element. Any questions at that point?
No.
Okay. So, okay. So what's the advantages of linked list? We already saw that this data structure allows efficient adding and removal of elements in the middle of the sequence. What does it mean? For example, if we want to insert new element at index 0 in an array, what we need to do?
We need to basically make a new array with that element at that place, and every single element moved by one.
Yeah. So what we need to do is allocate new piece of memory. And for example, we want to insert number 10 as a first element. So we need to insert this element. We need to create new array, the size of that array +1. We need to add this element, and we need to move all those elements in new places. So this is many operations. And imagine that you have an array not with 5 elements, but with billion of elements. You need to do billion of operations, literally. In situation with linked list, if you want to add new element, you just creating this element, and you just saying that next of this element will be previous first one, and previous of that element will be our new first element. And that's it. One operation. Yeah.
What if you don't want to put this element at the start or in the end and somewhere in between?
Yeah. So if you want to add it in between, we just create a new element. For example, 12. You're asking about array or linked list? Okay, so we created this element. For example, we want to add this element at index 1. Right now, or for easier drawing, let it be index 2. Right now, index 2 element is this one, right? So what we want to do, we will manipulate our next and prev values of those nodes. We have element 7. Next field of 7 node is looking at this element. We just saying that now next will be equal to this object. So we removed this connection. Then previous of this element is 7. Then our 9 previous will be not this element, but this one. And so I'm missing something.
Next 41, so we have previous ones for 12, which is 9. We don't have next.
Yeah, and next for 12 will be 9. So it works in any case, if it's first, last, or element in the middle, we need a small amount of operations to do those changes. When in terms of array, we need to move every element in array to do insertion. Any questions? Okay. Let's talk about big O. Can someone tell me what is big O notation is? Yeah.
Let's say some kind of algorithm,
Mhm.
like how long it runs, how long it takes, like the fast case or the worst
Mhm.
case. So the input is the number of cases.
Mhm.
Logarithm, and it's a phone.
Yeah. Okay. Yeah. Totally. So big O tell us what the show us the worst scenario for some algorithm. So let's remove this. Let's imagine some array. You know about linear search, right? What's the complexity of linear search?
All of them.
O of m. Why?
Because we have to iterate through every element array while we search for. So we stop only if we find the element.
Okay, but if I trying to find element 2, I need only one operation to find it.
But it's like the average. On average, we'll have to make all of n
Yeah.
iteration and n iterations.
But not on average in the worst scenario. Yeah. So all notation show us the worst scenario, and worst scenario for linear search for an array is when our element at the end, and we and n in this example is a number of elements of array. So in this example, the worst scenario if it's when we need to do 1, 2, 3, 4. No, 1, 2, 3, 4, 5 iterations to find our element, and 5 is our n. So this is worst scenario. If we would have array of billion elements, it would be a billion of operations. Then, for example, if we want to perform a bubble sort, what's the complexity of bubble sort in an array?
That's for
Yeah. Why?
loop inside loop. So first of all, we iterate. We take the first element and then iterate through every element in an array to check if it is great for it.
Mhm.
For every element, we have to check the entire.
Yeah.
Yeah. Yeah. Yeah. So yeah, you're right, guys. The worst scenario for a bubble sort is when our array totally unsorted, and we need to move every element through the whole array. And as you can see, here, as you can see, for us, the root complexities is O log n and O1, and On and On log n is already average complexity, but On squared is a bad complexity because the more elements we have in our array, for example, the slower this algorithm will be over time. So you need to aim to the n log n. And in another lectures, we will discuss some sorting algorithms, and you will see that bubble sorting is a best sorting algorithm actually, and we have better sorting algorithms that have complexity n log n. So let's talk about linked list in terms of complexity. So, can you tell me? Let's talk about array a little bit more. So, what's the O of operation of getting element in array? Yeah. So when we get element in array, our complexity is O1. Can someone else tell me why? Yeah, because as we discussed before, elements in array stored in such way that they are in the same place in memory. And if we know the index of element, we can get this element just simply calculating its address in the memory. So to have element, for example, with index 2, we need to just have this element to perform one operation. If we want to get element from linked list, what complexity will be in this situation? Can someone tell me how to get element in the linked list? So I forgot to tell you, linked list store inside this data structure stored the first and the last elements. So in linked list, we have reference to the first element and the last element. And this helps us to have any elements inside linked list. So tell me how to get some element.
Right. Starting with the first one until we find an element with an index.
Yeah.
We are looking for some.
Yeah. Yeah, that's right. O-N, and it's you can see the difference. So to have an element from an array, it costs us only O1, but in the linked list, it's already ON. Because, for example, if we want to have element 4, element with index 3, for example. So linked list does not store any indexes. I just show those indexes for our purposes, but actually there are no indexes in the linked lists. In linked list, only there are only next and prev values in nodes. So for example, we want to have element with index 3. We have first element and we check its next value. We go to this element. We check, we like adding 1 to our count variable. For example, we go to the next element. Then we go to the next element. And okay, we have element with index 3. But how we could optimize this search? Any ideas? We know first element, last element, and size of linked list. Yeah, but in this situation, we will do those operations. So for computer, like if we would do this in parallel, okay, this does make sense. But let's imagine that we have only one threaded processor, one thread, and we can do one operation at a time. So in your example, we need to check this, go here, go here, go here, go here, go here. So it's the same number of operations, but it's right move of thoughts. Maybe something else, maybe some detail. So we have size of our linked list. We know it's our input value. Yeah. So we said we want to have elements with index 3.
Correct.
We should check if it's more to be the last element. Or the first one.
Yeah.
One element that it's
Absolutely right. What? It's okay. So many topics. Okay, first of all, we can just get this element because we don't know the address in the memory where this element is stored. We know it's only through this chain of references of those elements. About binary search, I tell something about binary search later. And so this is right solution. So we can divide our linked list in a half, like imaginary. And we can check our index in the first half or in the second half. And if our element in the second half, we can just start from the last element and go backward using previous references. So we can start from index 4 and go back, and we will have this element. And if we want to find element 1, we need to start from the first element and go through the next reference. Does it make sense? So the actual complexity of getting element from linked list is actually O(n)(1). But in terms of big O, this is the same as O(n), because in big O we check our complexity in terms of progression, right? So O(n) and O(n) squared are different mathematically because O(n) squared is a parameter and O(n) is a linear function. So
Ladislav,
yeah.
sorry
Yeah.
for interruption. I can see raised hands in online in the chat, Yaroslav and Metro.
Yeah. Yaroslav, Metro, you can just say something when you want.
Okay.
Yeah, I have a question. So for this, we need sorted array list.
No, it's not an array list. It's linked list.
Linked list. Okay.
Yeah.
We need sorted linked list, or we can work with any data.
No, we can work with any array list because. But why are you asking? Why sorted linked list? What? I don't.
Because I see this principle with sorted array. So I asked, do we need
so-
sorted linked list?
Okay, I understood you. So this is actually a very different concept. So linked list is very different from the array. So in array, what we're talking about is when we're trying to find an element of some value, and we can, if we know that the array is sorted, and we want to find actual element, we can calculate from which side we want to start to find in this element. But here we're trying to find not an value, not an element with some value, but element with some index. And this is the key difference, because in array we don't have any problems to have an element with index. We just getting this element. But in linked list, we have some problems with getting element with some index. So we need to do some additional actions.
Oh, okay, thank you.
Okay, and Yaroslav.
Yeah, I had a question about just for clarification. We are dividing the size of array, yeah, by 2, and then we check. So compare values of our index and this size divided by 2, yeah.
Yeah, but not an array, a linked list.
Yeah,
Right.
yeah, linked list. Yeah.
Yeah. So we have size. Size equals 5. We divide 5. We have 2 and 5. We round it to, for example, to the to 3, and we know that 3, like so, 5, 2, 5, and then, for example, it's equals 3, and this means that everything that bigger or equal of 3, we need to start from the last element, and every index that starts that's less than 3, for those indexes we need to start from the first element.
Yeah.
Okay.
Yeah, thank you.
Any other question? Any question? This is a hard topic, and if you totally don't understand it, you can ask question now. Questions. Don't be afraid. Okay. In Java, we already have an implementation of linked list. As array list, we have linked list. And here you can see how we can use a linked list in Java. So we can create an object of linked list, and like with array list, it's a generic data type. So in those triangle brackets, we can pass the object, not object, but class, a data type that will be our element in our linked list. We can add last, add first, get last. We can remove elements. And I will show you. Let's go through those elements and create this linked list. So first operation, we're creating an empty list. Then we add last, Harry. We don't have any elements, so when we adding last element, actually we adding first one as well. So added Harry, and it's have its next field and pref field, but they are empty. They are null because there are no elements in linked list except Harry. Then we add first Sally. What we need to do to add first element? We need to create this node, and we need to link this node with our previous first one, right? So we say that we created this node, and we connecting its next reference with Harry. Brief is empty because it's our new first element, and brief of Harry we connecting with Sally. And now we have our linked list with two elements. Then we get first. So in a linked list we have two fields, head and tail. And head, it's our first element, tail, our last element. So in this example, head contains reference to Sally, and tail contains reference to Harry. So when we want to get first, we just getting our head and getting Sally, element of Sally. Then we get last. In this situation, we get tail, and we get element of Harry. If we want to remove first element, what does it mean? We don't remove it from the memory, actually. What we do is just for Harry, so we have first element and second element. We want to delete first element. So we get our second element, and we removing this connection. We're saying that pref now equals null, and next of Sally equals null also. So now Harry doesn't have previous element, and if node in linked list doesn't have previous element, this means that this element is the first one. So Sally, and also we also reassigning head. We're saying that head now is Harry, not Sally. So we removed this connection also. And as you can see, Sally already Sally still somewhere in memory. But in Java, we have garbage collector. And garbage collector works in such a way that it's searching, constantly searching for elements that have reference, that it's searching for elements, reference of which doesn't store in any other objects. So this element exists in the memory, but any other object in this program doesn't store reference to Sally. And garbage collector can see that this object not just used in this program, no one even remember about this object. So garbage collector is just erasing this element from the memory. Yeah, in abstract way. So, is this clear?
Which order we should always at first and last, or we can at first and then.
We can at first, or we can at first, at last. It doesn't matter. Maybe I didn't understand your question. So there are no actual difference in order that you're adding elements. Any other question? Okay, let's move on.
Can we add something in the middle?
Yeah, we can add something in the middle. We also have a method. I will talk about it later, but we have method, and also we have this method in the built-in linked list in Java. For example, add element at some index, and then we will add this element at some index, and I will show you this example later. Okay.
Yeah, sure. Thank you.
Okay. So another thing that we can discuss here is a list iterator. So what is a list iterator? And please please listen carefully, because you will create your own linked list and list iterator in your home assignment. So list iterator is a tool to work with linked list. So linked list is basically a data structure. We have first node. We have last node, and we have some information stored inside nodes. And for example, if we have inside linked list class, we have methods to manipulate linked list. For example, add first, add last, add in the middle, get first, get last, remove first, last, or some element in the middle. But it's a data structure. And if we want, what we can do in linked list is just to have, for example, second, third element. We can do it iteratively, going through this linked list. But linked list itself doesn't give you this functionality. For this, we have a list iterator. And list iterator helps us to work with linked list, to, for example, traverse it, to go through these elements. So here at the end, you can see that we can create iterator, list iterator, and we can do it from the method inside linked list, right? So we have object of linked list, and inside this object we have a method that give us an object of list iterator, and our list iterator have methods to go through the linked list. For example, iter next. This method will give us value of next element. For example, if we started from the first element, iter next will give us our first element, and in this case it's 9. Then we call iter next one more time. What we will have? 7. And our pointer in somewhere. I have an analogy for you. I have an analogy. So imagine search bar in browser, and we can have some text, and we have this blinking line cursor, right? And when we press arrow to the right, this blinking cursor moving to this place, and very similar in some way to this mechanic. We can imagine our iterator here. So at the start, our like cursor, our iterator is here. When we say an iter next, we get next element, and we move our iterator here. And now we have an access to the previous element in next one. And we can do next one more time. We will get this element, and we will move our cursor here. Okay. Also, we have method hasNext. And with this method, we can check if next element exists. Because in this situation, next element 8, it exists. But if our iterator will be here, there are no new next element. And we can check it with this method. Also, we can have previous. So here, as I said, we can go next and have next element, and our iterator will be here. Or we can go previous. We can call iter previous, this one. And we will have previous element in our iterator will go here. And also this iterator, we can add elements. So we can add element, and it will be added here. So if our iterator are here, and we want to add element, it will be added at this point between previous and next element. About this in more details a little bit later. Any question? From 1 to 10, how clear is linked list and list iterator for now? 7, okay. 8, okay.
It's a list. It is this structure. We can do stuff.
One will have practical parts, it will be 0 or 1.
Yeah, -2. Okay. Let's talk about realization. I will show you everything about realization of those things. I will not share this code with you during classwork, but you have ChatGPT, so you'll be fine. But let's talk about this code. So we have class node. It's just a class. Like I'm just a girl, and no is just a class. And as you can see, this is a generic type, generic class. Did you worked with generic classes before? Do you remember such structure?
Yeah.
Yeah. So, okay. Yeah. So how does it work? When we're creating an object of class node, we need to pass data type of its elements inside those triangle brackets. And generic types works in that way that we can work with this type inside the class, even we don't know what this type will be on the at the moment when we creating this class. So this is pretty dynamic structure. We will know what this type is only when someone will create an object of this class. Okay. So inside this class, we have our element. Like, let's draw this node. So we have element. Element is our number if we want to stick to our examples. So imagine that we created node and we passed int inside triangle brackets. We have field element. Also, we have field pref. We have field next. We have constructor where we set all those elements. Pref and next can be null, and this means that we have only one element in our linked list. If node contains reference only in next but not in pref, what does it mean? Yeah, and this element is
Up next, so is first.
yeah, and in different situation, if we have elements that have pref but next is null,
So is last element.
this is last element. Yeah. Let's move on. Linked list. Linked list also generic class. And for example, one more square linked list. And this class have few fields. First one is a first. And in this example, first is contains reference to this object, some object in the memory. And last, or head and tail. And when we have only one element in our array list, last is also this element. If we will add another element, our last will be will have what reference?
Reference?
Hmm?
No reference.
No.
First.
First is this element and last?
Last.
Yeah. 7. So when we create an and also we have size. And in this example, size is 2, right? And when we add in elements, we increase in size. When we remove in elements, we decrease in size. Like with an array list. So we have constructor, and when we create a linked list, it's empty. First and last element are null, size 0. Let's move to some methods of a linked list. So get node. As you can see, as we discussed before, first of all, if we want to get an element with some index, we check if this index less than a half of the size of a linked list. If it's less, this means that we need to start from the first element. If it's bigger or equal, we start from the last element. So let's continue our example. So we have 4 elements. Size now is 4. The last element is 1. And for example, we need to find we want to get elements with index 2. So if we can use our algorithm to do this. Is our index is 2, right? Is our index less than size, the half of the size? No. Our index is bigger than half. It's equal to half of the size. So we go to the else block here. So we create a reference, like our current node, to the last element. So we temporarily create a current variable, and we say right now we store reference to the last element. And then we start a loop. We starting from the last element, and we decreasing our I with every iteration. And we reassigning our current element with current pref. So our current element is this one, and we can access its pref field. And we're saying that our current now equal of current pref. Current pref, boom, boom, it's this element. Is this clear? Okay. So now our element is this one. We check. If I bigger than index, we continue. Our I will be equal 2. It's not bigger than 2, so we stop. And our current element is this one, and we return current. Okay. The same situation with the first element. Like if we will try to find element with index 1, we will start from the first one. Our current element will have reference to the element with index 0, and we will go not in the current equals current pref, but current equal current next. And like this, we have current, we can go next, boom, we reassigning our current element, and we do it iteratively. Any question about this example? Okay. At first, so when we want to add new element, at first, we first of all, we creating a new node. So let's create a new node here. Bless you. Next. Brief. For example, as you can see that we setting an element. For example, it will be 5. And also our pref value is null because it's a new first element. So pref is null. And already we setting the next element. And inside linked list, we know that first is this element. And we're saying that next will watch first element. Then if first element equals null, so if our linked list is empty, our first element will be null. And when we're saying that our next element of our new node is a next, is a null, this means this is okay for us, because if we have only one node in our linked list, it's okay to have next and pref null, right? But if we have already some linked list and we adding first element, new first element, we already can use previous first to set the next of our new element, new first element. Is this clear? It's a very important concept. Okay. Strange to ask you, is this clear? Because if it's not clear for you, you will not tell me, right? Okay.
But I think it's understandable. Right?
Okay, let's go. Yeah.
What do plus size?
Not like size plus plus. I will tell you. Let's finish with other code, and I will tell you what's the prikol with those pluses. So, if our first, like previous first, our first field in the linked list equals null, this means that our new node is our new first and our new last element, because it's the only element in the linked list. But this is not our case, because our first element is not null. So we go in the else. And so our first brief, what is first brief in this example? What? It's not null. This is our first. Our first looking at this element. So our first pref, what is our first? Yeah, it's null. Sorry. Yeah, it's null. It's null, but we're saying that our first pref equals new node. This is our new node. So now our first pref will contain reference to our new node. And our first, this one, we will reassign it. And now it will look here, right? So we have new linked list with new first element. And we have plus plus size. What's the difference between plus plus and when it's before variable and after variable? Only in order that compiler will assign this value. So in this example, there are no difference. We can say size plus plus, we can say plus plus size, there will be no difference. But if, for example, we have value, int value a, and we want to add count, we want to assign a count to an a. If we will write something like this, we will assign count and then increase count in size, right? But so a, if we do print a and print count, we will have and count equals 4, for example, we will have 4 and 5, right? But if we will write plus plus count, this means that this operation will happen before we assign this value. So in this example, we will have 5, 5. Yeah, but in this example, doesn't make any sense for me. Maybe Roman, maybe you know why it's plus plus size. Maybe I don't understand something. Maybe. Yeah, maybe.
Right, if we add first element, we write plus sign, if we add plus element, we write something.
Yeah.
I mean, probably.
Okay, so let's move, and also we need to update our size. It's 5. Move on. Add some index that I told you before. So first of all, we have our int I. It's index in which we want to add element. So first of all, we checking our size boundaries. I can be less than 0 and bigger than our size. Then, if I equals 0, we just use our predefined function add first. We saw it before, right? If I equals size, we use add last. I didn't showed you add last, but you can imagine it because it will be pretty similar to add first. And if our I at some point in the middle, in this situation, we will do some other stuff. So, for example, we have a new order of indexes. As I said, indexes are not stored inside linked list. It's our own abstraction. It works only like when you iteratively traverse your linked list, you can count your indexes, but it's not stored inside linked list. It's very dynamic variable. Okay. So, because for example, we just added first element, and now this element have index 1, not 0. And if we have stored our indexes inside our nodes, we would need to go through all our linked list and update all of those indexes, and this doesn't make any sense. So, for example, we want to add element at index 3. So we want to add element here between our element 2 and our element 3. So new element will be with index 3.
Like when we add a new element, we shift the rest to the right, like one place.
Yeah, in array, we shift elements physically, but in linked list, all of those elements have some address in memory. And when we add new element, those elements stay at the same addresses. We add element at some address and we connecting them with our next and prev references. So we actually physically don't move any elements to other places in memory.
So indexes actually don't exist. This
Don't
is-
exist.
Ah,
Super abstract. Indexes, it's for our like human monkey brains. Yeah. So as I said, before this operation, this element had index 0. Now it's have index 1. This element have index 3, but our add operation, this element will have index 4, and those indexes not stored anyway. They don't exist. This is a pure abstraction. So we want to add element. We're saying that our current, we getting an reference to our current element. This method get node. You already saw element get node. So we're using get node, and we're saying our current is this element. right? Then we create a new node. Create a new node with value -3, and we assigning already current its previous value, previous reference, prev, right? And next. So prev and next of this node. So prev, current prev, what is this? Oh no, sorry, my mistake. We're trying to add element with index 3, right? And we calling method get node I. So current must be not this node, but this one, right? Does it make sense?
Yes. First index. And we can make session starts with 0 or 1 as we want.
In your own realization, you can write, but does it make sense? Because other programmers won't be able to use your linked list properly because, for example, they would think that index started from the 0, but your index started from 2, for example, and it would be very strange for them, right? But you can do anything. You can even create such linked lists that will use letters as indexes, for example. And you will have some rule inside your linked list that A is a 0, B is a 1, and so on. And AA is 29, AB is 30, and you can imagine everything you want. And you will say, get element ABC. And your linked list will work on your rules. Great idea. Please implement it. For example. Okay. So we creating our new node with constructor node, and we assigning our pref with current pref element. So what is this? What is current pref?
Current pref for source element references second, like 7.
Yeah, so we have current. We go to the current pref, and current pref show us this element. So our new node pref will be this one, right? And our next element will be our current. And what does it mean?
First one was 2.
That one or second?
That one. Next.
This one.
No, the current is 0.
Yeah, current is this one. So
No.
next will show, will have reference to this element. Okay. So next, this is I like this one. So what is
Next.
current ref next? What is this? Current ref next.
Current ref next. So it's current itself?
No.
No.
We assign, so we had the previous element, the 7. Yes.
Yeah.
And then we assign the next element to 7 as -3. So it used to store the value of 0 as
Yeah.
next, but now we have -3, which will be next.
Yes, exactly. So we have our current element. Right now is our 0 element, right? We have field pref, and this field contains reference to element 7. And element 7 have field next and right now it contains a reference to element 0, but we're saying that our current pref next, this field is now equal to reference to new node, and we can tell that this, we remove this connection, and we're saying that now next of this element will have this reference. Does it make sense? Okay, I will not ask it anymore. I understood. Current pref equals new node. What does it mean?
The same.
So-
but
okay,
with the
same
next reason.
Yeah, so our current, it's have pref, and now it have reference to element 7. But we're saying that now current pref will have reference to the new node, our -3 node. So we're removing this connection and saying pref is now here. And we increasing size by 1. So now, if we want to traverse our linked list, our first element, this one, next one, 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 this one. Previous, this last element, previous of this, previous of this, and so on. I'm not asking you this question, but is this clear?
Yes.
Yeah. Okay. Okay.
Out of bounds extraction, remove,
We already covered.
makes sense.
Yeah, so remove works. Mm, okay.
I mean, by.
Because you want to be practical for it.
Yeah, yeah.
No,
Someone.
I mean, if I like.
Oh,
understand-
I prepared this lecture for the previous year, and I forgot. Here, our like practical assignment when you will help me to create this remove node algorithm. So, for example, we want to remove element with index. Let's update our imaginary indexes. So 0, 1, 2, 3, 4, 5. Let's remove our element index 3 because it's like in awkward position in this drawing. Let's remove it. So what we need to do?
Change this reference.
First step, we say that our current element is this one. Okay. So then what we do? Okay, so previous in such thing. So we have current dot what? Brief.
Equals current.
So current, previous, next
To current.
equals to current next. So this one. So one
Yeah.
and removing this. Okay. One operation is done. Next. Current dot
Next. Next graph equals to
Next graph equals
eight.
so current next, so this one graph this one, right, equals current graph. So one and removing this little arrow. Okay, so now
Do we need to add like the current graph equals null and current next equals null?
Why? We don't use it anymore.
yeah, we don't need, because our garbage collector, I have this analogy. So we don't do any dirty work with this node. We just throw it from the boat, and our shark garbage collector will eat it because it's don't attach to the boat anymore. So any of those nodes don't have a reference to this element. If these elements have, I can continue this analogy. If this element is trying to hold the boat, doesn't matter. Shark will eat it anyway. So for garbage collector, it doesn't matter if this element have any reference to other elements. If those elements don't have a reference to this element, garbage collector.
We're taking on the backend short.
Yeah, and also, yeah, because it's impossible to use it because we forgot this reference, and maybe we wrote it on some paper, but the garbage collector doesn't know that we wrote this address of this element on paper. Garbage collector think that we don't have access to this element, so we don't need it. Yeah.
Size minus one.
And size minus or minus size as you prefer. Yeah, linked list, so easy, right?
Could be worse.
Could be, it will be.
Okay.
Yeah, so do you have any questions about linked list?
So the main idea of linked list is to make it easier for our machine, for our to work with it, to operate with it.
For our machine, but it's very philosophical question, because for you as a developer, it's important to have your program optimized. You don't want your program be slow. So if you need to add element at some point, if you have such business task where you need to add element inside of your data structure, and you have billions of elements, you have some database. We have databases that work based on linked list, for example, and you can have such business task where in this imaginary database you need to have possibility to add elements very quickly in the middle of your data structure. And if you will store your elements as an array, and you have billions of elements, any operation with adding this element will take 2 minutes, for example. And your user will add menu, and he will need to wait 2 minutes. He will remove element from menu, and he need to wait another 2 minutes. And tell me, is this bad for you, for your system, or for your customer? It's all abstract. You need to create an optimized programs. So in some situations, you will need your linked list because of architecture of your system. And right now, you just need to understand concept of linked list, concept of stack and queue, to be able to choose right solution or create your custom solution based on those solutions, right? So this is about engineering, an engineering mindset. Now you trying to understand those basics engineering techniques to be able use them and create your own. So another question.
If I need to store it, linked list, so with arrays will be just store, but here we will change the references just if we sort or help sort.
Yeah, yeah. Or no, we can change a value of elements, for example.
Yeah, obviously.
Yeah, it will be.
I say you change the next ref of the element. So essentially shuffling themselves in the list, or you change the value itself.
Yeah. I think it's better to change just elements, shuffle elements, not references, because to shuffle references, it needs more operations to assign this and this, this and this. Yeah, something like this. Other questions? Okay, let's talk about stack. So in PDF, we don't have an animations, so we will, I don't know. Yeah, so stack. What is stack? Do you know what a stack is?
Yes.
Yeah.
Yeah, we learned about stacks a bit.
Stack Overflow.
Yeah, with Stack Overflow, and we learned a bit about stack in our previous programming course.
Yeah, so you had this analogy with runtime stack, right? With functions, with recursion, Stack Overflow. Yeah, so yeah, I forgot about this. You already. It was me.
Yeah.
Yeah, you
Okay.
told us about books.
Oh, wow. Sorry, guys. It's my age, you know. I'm old now. Okay, so we can create an realization of stack using our linked list. We can do this using linked list from the Java, or as in your home assignment, we can do it using our linked list that we created here and that you will create in your home assignment. So stack have only two methods, push and pop. Push, it's add element, and add element. Pop, it's remove, well, like get and get. So how we can do it using linked list? Push, you just add element, and add is a bad word. It's more like add last. So push means add last. For example, we added this element as last. And pop is what?
To get.
Yeah, get last, and remove last. And this is basically all operations with stack. Add last, get last, and remove last. So we will use linked list, but we will do only two operations: add last and three operations: add last, get last, and remove last. Is this clear? Super. What's in queue? Do you know what is queue? Okay, so queue is basically a queue. So like if in stack we have such thing like LIFO, last in, first out. In queue we have FIFO, first in, first out. So we have element, we added element, we added next element, we added next element, and when we removing element from queue, we're not removing last one as with stacks. We're removing that element that was first in our like process of adding data. Then this one and then this one. Also very cool GIF animation in this PDF. In queue, we have also two methods, enqueue and dequeue, like push and pop. Here we have add operation enqueue and remove operation dequeue. Some examples of queues. So print queue management. For example, we work in office. You have one printer and you have 100 people who want to use this printer, and system that works with this printer. It's queuing people who wants to print something. Like Michael want print 10 pages. He pressed print at 10:30, and Michelle want to print 20 pages, and she pressed print at 10:35, and this system will print them in queue one by one. Who was first will have its printed materials first. Spotify music queue. You adding your queue, you going through your playlist, you adding some tracks in queue, and you will you will listen these tracks in such order like you added it in queue. And realization. We have two methods, enqueue and dequeue. Our add is basically the same. We add element at last, right? But dequeue a little bit different. Tell me, how will dequeue work?
We will going to need in the first item,
Mm-hmm.
then we need to remove it.
We need to add it. So that's why.
Yeah, we need to get first element, and then we need to remove it, right?
Yeah.
So basically, we add last element. We then can add another last element, then add another last element. And when we want to dequeue, we get our first element and we remove it. And in this situation, we added this element. It was our firstly added element. And when we dequeue, we get on this element and remove it. And when we dequeue next time, we will have next first in terms of linked list element, but that what was added as a second element. And this is it. Do you have any questions about stack and queue? Okay. So guys, wow, we don't have any time for classwork.
That's actually what I wanted to say.
Yeah. But I hope you had a great time during this lecture and you understand everything because now you will need to recreate your own linked list in your home assignment.